Welcome back, students. This is the session number 4 from the playlist of semiconductor devices and circuits. The topic is the band theory of solids, and based on this topic I have written here 3 important points which will describe this band theory of solids in brief. So the first point here is that the electrons have got discrete energy levels in the different orbits, and we all know about it. But in the case of solids, the atoms are close to each other. Now, because they are close to each other, the electrons interact with each other, and at the same time they are also interacting with the neighboring atomic cores. This interaction is more for the electrons which are residing in the outermost orbit, whereas this interaction is almost negligible for the core electrons or for the electrons which are residing in the inner orbits. Now, the energy of the outermost electrons increases or decreases because of this interaction, which results in the formation of energy bands and energy gap. So this was the first important point. The second important point is when the spacing between the atoms is reduced, then a region is formed in which the energy bands merge with each other, and because of this merging there are no energy gap. But if the spacing between the atoms is continuously reduced, then the energy bands split apart and an energy gap is created, which is shown in this figure. So here the conduction band, valence band, and are the energy bands. So when the gap, or can say when the spacing between the atoms is continuously reduced, then these energy bands are split apart and an energy gap is created as shown in this figure. So this forbidden energy gap is the energy gap. Now, basically there are 3 types of energy bands, that is the valence band, conduction band, and the forbidden energy gap. Now, the valence band basically consists of the outermost electrons, or the electrons which are residing in the outermost orbit. Now, these electrons are also called the valence electrons. Now, these electrons include a sequence of energy levels which form the valence band, and this valence band has got the maximum occupied energy level. Now let's discuss in brief about the conduction band. Now we know that the valence electrons, they are loosely bound to the nucleus at the room temperature. And because of this, some of the valence electrons are able to move from this valence band easily. Now, these free electrons are responsible for the conduction of, or you can say they are responsible for the flow of the current in a conductor. Now, conduction band is a band which consists of these free electrons, or you can, in other words, we can say that these free electrons form the conduction band. And the conduction band has got a very low occupied energy level, that is, it is very low in comparison to this valence band. Now, let's come to the third energy band, that is the forbidden energy gap. Now, the forbidden energy gap is the gap between the conduction band and the valence band. And if this gap is more, then it means that the valence electrons are more tightly bound to the nucleus and vice versa. This forbidden energy gap is, as we have already discussed, that when the spacing between the atoms is continuously reduced, then the energy bands split apart and an energy gap is created. So this forbidden energy gap is created when the spacing between the atoms is continuously reduced. And here, in the case of the forbidden energy gap, some amount of external force is required in order to move the electrons from the valence band to the conduction band. So this was a short description about the band theory of solids. In the next session, I will be discussing about the semiconductors, insulators, and the conductors. Or we can say I will be discussing about the types of the energy band in detail in the next session, that is in the session number 5. So till then, have a nice day.